Problem number 4. When rolling 20 dice, what is the probability of at least one of them will show a 6? Okay, if you want to give this problem a shot, pause the video and let's see how you do. Okay, now, did you notice the key word here? At least. So when we say at least, that triggers in our head, okay, I need this and up. Now, I'm rolling 20 dice, so that means I could have either 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8. I'm not going to do that. I could have I could have up to 20 of the dice showing the number 6, and that would make me win the game. So no. So this is the absolute quintessential number one time where we want to say this is the complement rule. I'm going to do 1 minus the probability of what would make me lose. So if I want to show a 6, at least one showing a 6, then I want to know what's the probability of none of them showing a 6. So hopefully you counted this one just like you did the last problem. So 1 minus. All right, now denominator 20 dice, and again, dice always have 6 choices, so therefore I'm going to do 6 to the 20th, right? 6 because 6, decision 1, decision 2, decision 3, decision 4, right? All the different decisions I have to make when choosing my 20 different dice. First die I have 6 choices, second die I have 6 choices, third die I have 6 choices, so on and so forth, right? So multiplication principle says it's 6 to the 20th. Numerator. Numerator is my event where I want none of them to show the number 6. So we rig the game. We guarantee it's going to happen. We are going to guarantee, first things first, out of my 20 dice, I'm going to choose all 20 of them. And then for my faces, I am going to choose out of the 5 remaining faces. When I put a 5 here, what I really mean is they could have a 1, a 2, a 3, a 4, or a 5. Any of those is fine, just as long as it's not a 6. So out of my 5 faces, I'm going to choose one of them for every single die, and I'm going to need to repeat that process 20 times. So I raise it to the 20th. Okay, and there we go. That's our probability. Yay! Amazing. And again, if you want to work it out, you absolutely can. 20, choose 20, that's 1. Or 20 combinations, 20. 5 combinations, 1 is 5, raised to the 20th, divided by, I don't know 6 to the 20th off the top of my head. Yeah, don't got that. But there you go. So that would be kind of an even more simple version of the problem. Okay, let's look at another one. Now, when you're playing the game Yahtzee, you roll 5 dice. Okay, a Yahtzee is when all 5 dice show the same number. So when you roll the dice, and if you got all 5 dice, all of them were showing the number 2, for example. So we got a 2, a 2, a 2, a 2, and a 2. That would mean you got a Yahtzee, and you would yell Yahtzee, and then the whole world would applaud. Okay, so what is the probability of that happening on your first roll? Because in the game you do get multiple rolls, but I'm just going to ask you, what's the likelihood, what's the probability of this happening on your first roll? All right, give it a shot, see what you can figure out. Okay, here we go. So what's the probability of getting a Yahtzee? Well, the denominator, it's the same thing, right? What's the sample space? I'm rolling 5 dice. Each die has 6 sides, and I'm going to do it 5 times, so it's 6 to the 5th. Okay, numerator. Now, take care of your condition first. So let's see. If I have 5 blank dice and I see all 5 dice floating up in the air, I'm some higher power, and I have all 5 dice, I look down and say, I'm going to let Jennifer get a Yahtzee today. Yes, my name is Jennifer. I'm going to let Jennifer get a Yahtzee today. So first decision. What is the first die going to be? Right. Well, I have 6 things to choose from, and I need to pick one of them. Right. Now, once I've done that, if I've decided, okay, it's going to be a 3, then what does that mean about the other die? Well, it's got to be the same thing, right? Because otherwise it's not a Yahtzee. So once I make my decision for the first die, I've actually made my decision for all the die, haven't I? So therefore, I'm done. It's 6 over 6 to the 5th. And you could, of course, simplify that to make it 1 over 6 to the 4th if you'd like. And there you go. And get a decimal version of it if you're, whatever your learning management system wants you to do. But that's the big idea. All right, I hope it helps. Let's do one more. So instead of dice, we're now going to flip 20 coins. What's the probability that there will be exactly 3 of them with heads? All right, so give it a shot. Very similar to the dice. So give it a try. and let's see how you do. All right, now 20 coins. So again, imagine you've got 20 coins and they are all distinguishable because everything in probability is distinguishable. I don't know if that's 20, whatever. All right, first decision. What's the first decision you have to make? Well, actually, probability of getting 3 heads. Okay, there we go. Denominator. Let's just start with the denominator. What's the total possible number of outcomes? Well, each coin has 2 choices, right? And I need to pick one of those, and I'm going to make that decision. We had 20? Yeah, 20 times. Or, AKA, that's just 2 to the 20th. Fantastic. Numerator, here we go. All right, first decision, guaranteeing heads. So first thing I gotta do is decide which 3, maybe that one, and that one. So out of the 20 coins, we need to choose 3 to get a heads. Now, once I've chosen these 3, do I actually need to decide anything? Like with the dice, I would have had 6 different possible outcomes. But with the coins, well, I've chosen that these are heads. So therefore, there's really nothing to be decided. Out of the one option, I'm going to pick that one 3 times. Right? That's just 1 to the 3rd. I don't need it. All right, so that will go away. All right, so that's done. I've decided that's a heads, that's a heads, that's a heads. So now what's left? Well, out of the 17 other coins, I'm going to do all 17 of them. And what decisions do I have to make? Well, none, because if they're not heads, they have to be tails. So therefore, I have one remaining choice, and I have to pick that one. I have to do it 17 times. So if you realize the 17 combination 17, that's just 1. 1 combination's 1, that's just 1. Raised to the 17th, still 1. So I don't really need any of it. So it all just boils down to 20 combinations 3 divided by 2 to the 20th. All right. Well, I hope this video was helpful in kind of getting that idea of counting a little bit more solid in your brain, and we'll see you in the next video.